All right, well, good morning and happy Friday. We'll take a look at a couple things today. In particular, I want to spend some time going over some web scraping. And so, we'll do some importing and exporting. Just how do we get our data into R? And we've seen some of these things already, like probably read.csv. I imagine you are familiar with as far as reading in data files, but you have other commands as well. Read line will read in lines from I guess from the standard input, which is how you interact with R. When it'll basically ask for a prompt and you can type in and it will just receive whatever you type in. Read.table can also be used to import just any kind of text file, whether it's, I don't know, tab separated or things like that. You can also specify the delimiter. There's a argument, strings as factors. The default is now false. It used to be true, and you would have to set this false, but now strings as factors is defaults to false. So less of a concern, but perhaps something you might want to just watch out for. Okay, we've got other packages that are useful as far as reading in data. So we have readr, and this is from the Tidyverse. And I would say readr is one of the best packages as far as reading in data goes. There's other packages as well, but I really like readr, so that's that. And then we have, if you're dealing with Excel files, you can do read Excel. And then if you're dealing with some other statistical software like SAS, SPSS, or Stata, then you can use Haven. I don't know if you've ever touched any of this stuff. It used to be more common, but I think now that Python has kind of really overtaken machine learning, and then as far as traditional statistical analysis, I'd say R still kind of dominates now. SAS does exist out in like some government organizations and things like that, but yeah, I'd say now you're mostly dealing with R and Python, and then Excel is always popular because these spreadsheets appear everywhere. And then there's also data.table, which is useful as far as bringing in big files. Okay. So anyway, readr comes with a bunch of these things. These all have underscores, and you have read CSV, TSV, delim, FWF, table, and log. And so these are for all kinds of different things. Fixed width files is basically when you open up the text file and all of the text is kind of lined up nice and neatly, because everybody, they put spaces in rather than tabs or commas. That's what you have. And then, the month names was a tab separated file, and you have these different kinds of things. There's also a package data.table, and that comes with its own function called fread, kind of like fast reading. And I would say this is the function you should use if you have a very big data file, so something like over a gigabyte, something like that. Then fread is going to give you the best performance. If you have, on the orders of millions of lines. So if you're under a million lines, read CSV probably fine. Well, I guess it depends how many columns you have. But if you've got a lot, then fread is going to be the fastest choice there. Okay, this I just copied directly from the readr page, and it just said, how does readr compare with fread? And basically it says fread is going to be the fastest. Readr, has a little bit more of a sophisticated parser, and it's able to kind of recognize double and backslash escapes and things like that. whereas fread will also try to automatically guess things and so on and so forth. Okay, if you're dealing with, say, Excel files, you can use read Excel. Okay, so that's read X, the letters X and L, and then the command to read it in is read underscore the name Excel, and then you'll do datasets.xls, and the XLS files. You can have different worksheets within a notebook, and so you can specify the worksheet by the name of the worksheet or the number, which worksheet number you want to work with. And like everything else in R, it's one indexed. Okay, and then occasionally you'll want to download a data file from the internet, and R has its own native function that can be used for downloading. It's download.file, but it's an old function and it doesn't work very well with modern day internet. So pretty much almost every single website you visit on your browser in like a day-to-day basis uses a secure HTTPS. I don't know if you ever pay attention to this, but there's HTTP, which is kind of the original hypertext transfer protocol, is just how internet websites were distributed, and then they've made it secure, and you will see HTTPS. And pretty much almost every single website today now employs this. And in fact, your browser, if you try to go to a website that doesn't use HTTPS, won't even take you to the site directly. You'll get this warning page that says this page is not secure and things like that. Anyway, download.file was produced during the time where nothing was secure and you could just download things. But now if you try to use this on any kind of modern website that uses S, it breaks. Okay, so anyway, you'll want to install this library called Downloader. Okay, install that package as Downloader, and then you can just provide basically the web address. So here is just the web address of a CSV file. Sometimes you have CSV files just floating out on the internet, and then you'll call something like download, and then you'll provide the web address, download the URL, and then you'll give it the name of the file where you want to store it. This is going to get stored in whatever your working directory is, right? So we talked about setting your working directory and making sure you know where it is, and then so you can just download. It will save whatever thing is out there on the internet down to it'll save a local copy, and then you can just do read underscore CSV with your local copy. Okay, and so that will get loaded in, and that's a package downloader. So something you should I recommend having installed. Sometimes you want to save objects or files for use later. Okay, if you're going to be working in R in the future, you can just save it in the native .rdata format, and so you'll just call save, and then you'll call name whatever objects you want to save. So whether it's a matrix, vector, list, function, you'll just name them off, and then you'll say provide the file name, and then you'll call it whatever data data file you want to store, and then later on you can load that up, and it will load those objects into your environment or your workspace. Okay, if you want to save things as plain text files, you can call write, and so for example, if you want to store an atomic vector into a plain text file, you can call write x, and then you'll give it the name file.txt, number of columns 1, and it will store all of the values in an atomic vector into a plain text file. And then if you have a data frame, that lends itself to basically a tabular format, so you can do something called like write.csv. The default arguments of write CSV is it's going to save the row names, and the default row names for data frame are basically like row numbers: row 1, row 2, row 3, row 4. And I don't know, maybe you want that. A lot of times you don't, so you'll do something like row.names equals false, and that will save your files for you. Okay. All right. Oh, let me just go ahead and give you your first view quiz answer today. which is the letter, I think E. Let me just double check. Yes, E. E is your first answer. E as in elephant. Okay, this is just to kind of talk about working with dates in R. Working with dates used to be a huge pain, and well, I would say without this package, okay? So, and it's still a bit of a pain. And then if you go to, say, Python, it's also kind of a pain working with dates and times and things like that, because you have to use this. I guess that there's like an international standard for like how date strings are formatted and stuff, but it's annoying, okay? And so there's a package called Lubridate. I guess it's a play on words on lubricate, which kind of smooths things out, but for handling dates. So let me just show you. So this is just this slide. Don't worry about this slide. This is just to show you what a pain it is to work with date information. So let's say you have a string and it's typed out as January 15, 1999. In order to get R to understand this, you call the function as.date, and then you have to provide the format, and you have to remember %B is for name, the full name of the month in English, and then %d is for the day, and then %Y is for a 4-digit year. You have to have the comma there, otherwise it won't understand. So if you happen to forget the comma, or you just have something formatted just a little bit off, it's not able to read in the date, okay? Here I've got 12/15/2001, so that would be December 15th, 2001 or whatever, and you have to have the string formatted this way. Notice the month is a lowercase m rather than a capital B. You have to kind of remember all of this thing. And again, if you mess something up, like you have a dash instead of a space, it breaks and it's not going to understand that, okay? If you have a vector with dates in different forms, okay, like we understand this. This is January 15th, 1999. This is December 15th, 2001. This is March 18th, 2002. Like we understand this and we can read this, but as far as using as.date, it only supports one format at a time. So it could either import the first one, but can't import the other ones, or it can import the middle one, but can't import the others, or things like that, right? So we have these different forms so it's a bit of a pain, okay? With library Lubridate, okay, you load that up in there, and you have the same exact vector of dates written in string form, and you just have to say, oh, you know what? The information is coming in month, day, year. Month, day, year, and then this is able to understand all of them all at once, okay? No formatting, no need to say like, oh, there's a comma here, or there's a dash there, or there's a slash here. It just says, oh, the information's coming in month, day, year, and then it's smart enough to figure it out, okay? Now you do have to specify month, day, year, because otherwise dates will be ambiguous, right? So if you have 03, 04, 05, that could mean all kinds of things depending on whether it's year, month, day, year, or a lot of the world uses day, month, year. And so, all of these things would be quite ambiguous if you don't specify. So Lubridate does require that you have to provide the order in which the dates come in. Oh, here's a question. Is date a numeric variable or categorical variable? What's the criteria for something to be a numeric variable? So numeric variables have to record a quantity, okay? And so do dates record a quantity? They do. They do record a quantity, okay? And that's why we can make comparisons. So here's a way you can think of, is something a numeric variable or not? You have to ask, does it make sense to compare one thing with another and say there's more or less? And so as far as dates go, You can say like, oh, I was born this day and you were born that day. I'm older than you, okay? Like that's a comparison that makes sense, okay? Versus something like area code or zip code. Like if you think about your phone number, even though it's a number, it's not numeric, okay? Your phone number is not numeric. Like I wouldn't say like, hey, what's your phone number? And then what's your phone number? Oh, you have more phone number than him, okay? That comparison doesn't make sense, right? There's no quantity represented. Even though it's written down as a number, there's no quantity represented, so it doesn't make sense to do a comparison. As far as dates go, and it's strange, but we've all agreed upon this really wonky system to record how much time has passed since, this arbitrary point in time, right? Like the year 0 or the year 1, and we've based it off of like Jesus, and that's just kind of like the as a world, we've agreed that this is like the system we're going to use, and that we're going to say the first 31 days belong to this thing called January or the first month, and so on and so forth. It's a little bit weird, but it's basically like how much time has passed since this kind of arbitrary moment in history, and then and so we compare that. In fact, if you look at on the computer, dates are stored as basically how much time has passed since the epoch date. And the epoch date is just arbitrarily selected as January 1st, 1970. Okay? So if you look at, like, if you convert a date into a number and it's January 1, 1970, it'll be either a 0 or 1, I forget. And then if you look at January 1st, 1971, it'll be like 365, and so on and so forth. And then 2 years later would be, whatever it is. January 2nd would be like 366, and January 3rd would be 367, so on and so forth. And so that's how dates are recorded. Dates are numeric. That's why we can do numeric comparisons and say this day was 30 days before the other day, and those kinds of things make sense. Even though we write it down in just this completely weird way that doesn't really make sense, right? But anyway, that's what we have. All formats. Oh, okay. So if you give it something and it's not going to work, right? Like if you say 25, 12.99, by our brains we could say, oh, okay, that's probably like December 25th, 1999, based on this. But if you tell Lubridate like month, day, year, and it tries to look for the 25th month, it's going to be like, I don't know. This doesn't work, okay? All right. Let me introduce package RVest. RVest is used for web scraping or harvesting the data from the web. And there's a couple pieces that you need to use. And you'll download RVest, and you can and you'll need to install something called the selector gadget for RVest to work as far as selecting the bits of information that you will use. Now, RVest works great if you have a mainly static web page with well-defined HTML tags. So I don't know if you're familiar with how websites are written, but what your browser does is it reads in this HTML page. There's kind of this little language of like how to format text. It's the markup language, hypertext markup language, HTML, and at its basic form, it basically says like this paragraph should be formatted as a header, and this paragraph is a paragraph, and this bit of text is a link. It's an anchor, and insert an image here and stuff like that. Okay. Put in a table. And you have all of these little tags that show up all over the page. And RVest is good at reading that in and understanding that. Now, a lot of the websites you look at today are dynamically generated. So anything that has an infinite scroll, okay, is going to be dynamically generated. And so a lot of the web pages, a lot of the things you use now have infinite scroll. You go there, And as you scroll towards the bottom of the page, it automatically starts loading up more stuff, okay? And so you can scroll forever. And that was a design choice so that you don't realize how much time you've been spending on the website, because if you reach the bottom of the page, your brain has to go, oh, should I click the next button and go to the next thing? But if you don't, and you just can just scroll up, your brain doesn't have to ever think about that, and and you can stay on the page forever. But anyway, so Arvest works better for these older things, and so it doesn't work well for some of the new things. Also, if you have to be logged in, okay, so basically everything on Facebook and Twitter or X or whatever, like if you have to be logged in to view content, Arvest is not going to work for that. So there are other solutions for dealing with sites like that. So you have different scraping tools. There's what's called the Selenium browser, but that's like way more involved. And so as far as like having just one lecture introducing the concepts of web scraping, we'll start here, okay? So this, I'm gonna go to Reddit, okay? So if you go to, so the new Reddit, here, let me actually log out. Okay, so if you go to, like if I go to the regular Reddit, this is a page with infinite scrolling, and so like I reach the bottom and it automatically will load up more stuff, okay? And so this page not going to work well for Arvest, but you can look at kind of like the old Reddit, and then this thing does work better, and you can look at the page source. That's a little bit hard to read. You can click inspect, and there's a whole bunch of like there's a bunch of kind of code here, and you can kind of hover over and see like what part of the page this stuff refers to. Okay, so each, like as I hover over this block of text, it highlights a different kind of piece of information, okay, on the site. So anyway, if you can look at this, and if you look closely at it's even if it's kind of hard to see, there are certain pieces of information. Like if I scroll into this these div tags, okay, it says like div class up arrow and div class score dislikes and score unvoted and score likes and things like that. There's these different chunks here. Down here there is the list buttons, which have things like the comments and share and save and so on and so forth, okay? Post, all of these things. And so, you know, if you look at, this is just like a simplified version, you'll have these different tags, and they'll say things like first and share button and save button and hide button and things like that. And you can tell the Arvest program or to go through and look for anything that says share button or save button or comments, and it will kind of look for, you know, a particular number. So here we're going to say look for comments, and it's going to say there's this many comments, and we can try to use that to extract that information out. Okay, so there's something called a selector gadget. Okay, and I'll just go to selectorgadget.com, and there is just this little bookmarklet, okay? And it's actually a little piece of JavaScript, right? And you can, you know, if you have like your bookmarks bar, you can just kind of highlight and drag it up there, right? And put it into your bookmark bar. And I already have it dragged up there, selector gadget. And what this will do is I can, from selector, if I'm on the page and I click selector gadget, okay, this little thing down here appears, and now I can kind of hover over different elements, okay, and I can say, you know, I want to extract out different pieces. So when I click something, like a whole bunch of stuff highlights in yellow, and I'm gonna click something and say, like, I don't want that, but I do want, yes, so I do want everything that's in yellow and green. So here I want the comments, 7,449 comments, 3,970 comments, this and this. And it says, okay, if you want to select that piece of information, the tag that you need shows up down here as .comments. So anything with the .comments tag, okay, will get selected, and it's going to select those things. So if I use the tag .comments, the selector gadget will identify all the text that's surrounded by one of those HTML tags, and that's how we're going to select it. And so if I do that, and I would read this in to Arvest, I say read HTML, okay? Read HTML, and the site I want to read is going to be https old.reddit. So let me see if I can copy this and run this in R. All right, let's see if we can read that in here. So I'm reading in old Reddit right now, and then let's see if the comment counts. So if I go to comment counts right now, it says 7,495 comments, 4,000 comments, 7,599. And let's go back to the Reddit website right now. Let me just refresh, and I think we're getting pretty close matches between what. So 7,000. Okay, I guess 495 when I did it. Now it's 4,001, 7,599, 3,856. I don't know if you guys can see these numbers here, but they're kind of aligning. If I select a different thing, so let me go to selector gadget, and I'm going to say I want to get the headings, okay? So we're going to select all of these things. I don't want this, so I'm going to just select .title, okay? That's the thing I want. Oh, I don't want these. Okay, so we're going to take, that's the tag I want, and so I'm going to say we're going to go with the old Reddit site, and then the node that I want to select is going to be .title, and let's see if we can get that. All right, and so if I select .title, okay, indeed, this is kind of what I'm getting. Google Earth has begun updating images of Gaza. Dad refuses to turn on heat in winter. I'm a liberal, but Reddit is insufferable right now. So on and so forth, right? So these labels, okay, or titles are showing up, and they get imported in. And so the browser is just going on and scraping out the information. Now, some of these things are getting duplicated and so on and so forth, but it seems like it's running and it's working. Okay, so that's done by doing read HTML. Read HTML reads in basically the HTML from that web page. Okay, and then are you familiar with this? This is called the pipe, and basically allows us to take the output of one thing and process it with another function. So I'm going to say, all right, so we're going to store read HTML into just an object called old Reddit. And from old Reddit, what I want to do is I want to read all of the nodes that contain a certain tag. So if I can say I want to read all the nodes that contain .comments, or I want to read all the nodes that say .title or something like that. And then after that, I want to extract out the text associated with that node. And that's what we're doing, okay? If I have something like this where I've got all of these different comment counts, I could try extracting out just the numbers, and this uses a regular expression where I just say, hey, search for the digits, and I can do that, and we'll cover regular expressions later, as they're super helpful, but for now this is just like extract out anything that's a digit. So back here I had 812, 14,162, 9,098, and I'm just saying just extract out the digits. Okay. So I said, sites that require logging in or infinite scroll. Those are not going to work well. Okay. All right. So easier, yeah. The old Arvest. So I've got this with. I ran this I think last night, and they had highlights with Nikola Jokic, and from basketball and so on and so forth. Okay. Yeah, these are other options that you have for web scraping. And again, if you need something that's a little bit more advanced, you can use RSelenium. And then if you really want to get into a bunch of kind of web scraping stuff, then you might try switching languages entirely and switch over to Python, and you have a handful of tools in Python. You've got Beautiful Soup, ScrapePy, and then also Selenium as there. Okay, let me go walk us through a demonstration with Arvest, where we're going to do some, I think, some pretty neat stuff. Okay, and so this what do you call it? Script is available on Brew and Learn, and you can download and follow along. You're going to have to install a few packages. Let me give you your second view quiz answer, which is the letter B. B as in bear. B as in bear. Okay. So there's a few libraries we need to load. One is we need to load up Arvest, but we also need to load up a library called Polite. And then Stringer is going to allow us to deal with regular expressions. But what Polite does, and sorry, I didn't include any notes here, is it allows us to visit websites as a bot, okay? As a bot, and it allows us to kind of scrape information from the website, and then, as a bot, visit another page, scrape information, and do things like that, okay? Now, a lot of sites have features that block bots, okay? A lot of sites don't allow for bots, or what they don't actually hate bots themselves, but what they hate is that with a bot, you can keep pestering the website, okay? So, as a human, you click a web page, it loads up, you follow a link, and you might follow a link, and it takes you it's a few seconds in between each link that you click. But if you're a bot, you can keep kind of calling, asking the website, I want this page, and then a quarter second later, or 5 milliseconds later, you make another request and another request, and you can generate hundreds of requests within a couple of seconds, and that overwhelms the server, and then it can cause the server to crash. And so they hate that, and so if they detect that kind of behavior, they will block you, okay? Or they will do something called rate limiting. So they will say, hey, this web address, this IP address keeps hitting us, and so we're going to rate limit them. And they're going to say, hey, you're not allowed to make any more requests for 5 hours or something like that, okay? So what Polite does is it says, oh, hello, I'm a bot, but I promise I'm only going to visit you once every 10 seconds or once every 5 seconds. I'm going to do a reasonable amount, so let me in. I want to scrape your data. I will wait patiently before making another request. And a lot of sites are okay with that, okay? So that's what Library Polite does. All right, so to demonstrate this, we are going to visit IMDb. So IMDb is, there's a lot of kind of stuff there, but it's mostly static, and so it works just fine. So I'm going to go into IMDb, and we're going to go to the web page for the Barbie movie, and we're going to say, we want to extract out some information from this web page, okay? All right, so let's say we want to extract out the IMDb rating, okay? 6.8 out of 10. So I'm going to use Selector Gadget, okay? And I'm going to highlight, hover over the pieces of information that I want. So here I just want to extract out this number, 6.8. So I'm going to click it, all right? And it says the piece of information we want is going to be, sorry, I'm laughing at the trailer here. .imuuxf. Okay, so now that doesn't mean anything to us, but apparently this is the piece of information we want. It says there's a little 2 here that says it's going to pull out 2 pieces of information here, but I don't see anything else being highlighted. So sometimes like information is like double embedded. So anyway, I'm going to copy this .imuuxf, and we are going to go back to R, and we're going to say, hey, that's the node I want to extract. Okay, so the first thing I'm going to do is I'm going to read the HTML from this web address, and I'm going to store it as the Barbie page. Okay, and so so RVest goes to the website, it reads in, and it stores it as Barbie page. Now, if you look at what Barbie page is, it's just this list, and it starts to have all of this kind of stuff. It's an HTML document. Okay, so what I want to do is I want to extract out the nodes that contain this. So I'm going to just kind of show you what it's doing. So if I take Barbie page and I pipe it in just to the first part where I just say, hey, extract out this node here, IMUUXF. Okay, here it says, okay, I've found that tag IMUUXF, and it surrounds the number 6.8. Okay, so I'm going to say, all right, but it pulls out the entire tag. Okay, the entire tag is span class sc deep whatever IMUUXF 6.8 span tag. Okay, so we're going to say, I just want to get the text that's in between the tags. Okay, so we're going to say, I want HTML text. So I'm going to just run that part. Okay, and it says, okay, the text here is 6.8, and for whatever reason it shows up twice. That's fine, but this is in quotes. It's a character, so I'm going to say I want to make that numeric. So I'm going to pipe that in into numeric, and then so now that converts the output down into the numbers 6.8. Okay, and so everything we're going to take all of this and store it into rating, and so now rating is a vector with the values 6.8. Okay, and so that's how I would go about extracting from here, a piece of information like that from the web page. Now you can do even more. Okay, so let's say I want to get the actors who are in the movie. Okay, so I'm going to go over to Selector Gadget, and I'm going to say, you know what, I want to get the actor names. Okay, so I'm going to highlight over the piece of information that I want. So I'm going to click Margot Robbie, and then and Selector Gadget automatically selects basically what it thinks I want. Okay, so and it did a good job here, right? It selected Margot Robbie, and then in yellow it says this is also the things I'm going to select: Ryan Gosling, Issa Rae, Kate McKinnon, so on and so forth. It says I'm going to get 18 pieces of information, and that looks like what I want. Okay, now if sometimes Selector Gadget gets it wrong, okay, and like you select something, okay, and it's going to select like more than I don't know, okay, like it selected like more than what you want, I don't know, okay, then you kind of have to mess around and say, I don't want this, I do want that, so on and so forth, and you have to kind of mess around with Selector Gadget. But here it looks like Selector Gadget's going to get the right thing when I hover over the name of the actor that I want. Okay, and so I'm going to copy this, and in R I'm going to say, okay, from the Barbie page, what we want to do is we want to get that tag. Okay, and I think the tag that I already forgot, I think I already did it correctly, but the tag is KVDWAO, right? And don't worry that it means nothing to you. This is just internally, this is what the web page is using to identify it, right? Like the Reddit site had like easy to understand tags like comments and share link. And some sites, they just have gibberish, and that's fine, okay? But here we're gonna say, okay, from the Barbie page, extract out the nodes that have the KVDWAO, that's gonna be the cast, and so extract out, after you do that, extract out the text. Let's take a look at the cast, and indeed it got our actors' names: Margot Robbie, Ryan Gosling, Issa Rae, Kate McKinnon, and we have all of these other people. Okay, You can extract out even more. So from this thing, let's say I want to extract out like a movie review. Okay, here it says Barbie, a multifaceted exploration of femininity, consumerism, existentialism. And I got free tickets for a preview, blah, blah, blah. Okay, so let's see if this extracts that out. So I think if you hover over Selector Gadget and you select this page, okay, then it says this is the tag that we want, IPC HTML content inner div. And I think I have that over here. And so let's see if we got that. Okay. All right, so under the review, it says I got free tickets for a preview, et cetera, et cetera. So it extracts out the information from the page, okay? So you know, these are how we can get all of this stuff. Okay, let me also show you what I want to show you is the automatic browser. And so I'm going to say what I want to do is I want to start on the Barbie page. And then what I want to do is I want to visit each of these actors' pages. So what I want to do is I want to go to Margot Robbie's page, and I'm going to visit Margot Robbie's page, and let's say I want to get the projects that she's in. Okay, so I'm going to go to Selector Gadget, and I want to get these other projects. See You at 5, Barbie, Asteroid City. I think maybe even like these upcoming ones. And I think if I select this, it's going to select these. A big, bold, beautiful journey, Wuthering Heights. Oh, they're making that. Okay. And then, et cetera, et cetera. So let's say I want that, okay? And so, for that, I would visit, I'm going to read in a new HTML page. This is going to be Margot Robbie's page, okay? And then from her page, I'm going to extract out the nodes that contain this. This is the tag. I'm going to select the HTML text. And so her projects are listed off here. And we can see, yeah, a big, bold, beautiful journey, Wuthering Heights, See You at 5, Barbie, et cetera, et cetera. Okay? All right. And so what I want to do now is I want to kind of have this automated browser, which is going to start on the Barbie page and kind of go through the different actors. So I visit Margot Robbie's page, then we're going to go to Ryan Gosling's page, okay? And then we're going to do the same kind of thing for Ryan Gosling. We're going to download these project names, and then we'll go to Issa Rae's page, and we'll download Issa Rae's project, Seen and Heard, Mo Waffles, One of Them Days, okay? And then we'll go to Kate McKinnon's page. So that's what I want to do. So how do we go about doing something like that, okay? Well, here, this is where I create a new session, okay? And so we create a new session with our browser, or we create a new browser session, and we call bow. And this is going to kind of, using the polite package, we bow and we nod, okay, to the servers, okay? And we say, oh, server, please let me go through, even though I'm a bot, okay? So here, this is the web page of the Barbie page, and we're going to start a session here. And so this is different from just reading in the HTML. This is just opening a session. It's kind of like telling your browser to go visit that thing. So let me hit session. So I've opened up a session. So now I have a session. All right. And so the first thing that we are going to do is, now that we have a session, like the basic thing is we're going to say, hey, give me the content. So from that session, we say scrape the content. Okay, so I say scrape, and the content that we want to get is the HTML, and so I'm going to get the page content. Okay, and once I have the page content, we're going to get things like the list of actors. I already have that. Okay, the cast. Okay, so I have the cast. But I also want to get, like, all right, when I hover over, I don't know if you guys can see this, there's like a little information that pops up that says, like, this is the page that you're going to go to, okay? And so I want to extract out the URL that I'm going to end up going to. Like when you hover over, anytime you hover over a link, I think usually like this little thing in the lower left corner pops up about like what page it's going to take you to. And so we want to get that. And that can be found using the same exact tag, okay? HTML nodes, we want the same tags, except the piece of information we want is the href, which is hypertext reference, basically the URL that we're going to go. And so rather than getting the text, we're going to get the attribute. So let me just kind of show you, like if I go to page content and just get those tags, okay, there's the tag itself has a whole bunch of information, like the title, cast, item, actor, and then this is the web address that we want to go to. Okay, so we want to get that the reference, the href. Okay, so we're going to get the actor URLs. So I'm going to extract out the actor URLs, and these are all of the web addresses. So if I type this in, if I do like imdb.com/this, this will take me to Margot Robbie's page. Like if I do www.imdb and I type in, hit paste in that reference, this will take me to Margot Robbie's page. Okay, and if I copy and paste this thing, this will take me to Ryan Gosling's page, right? So if I go to IMDb and imdb.com and then I do /name this will take me to Ryan Gosling's page. Okay, so so this is what I want to do. And so to kind of make this work, I'm going to take my vector of URLs and I'm going to name the vector by attaching the cast names to that, right? And so now I have a vector where Margot Robbie goes to her URL and Ryan Gosling, and I can extract out, whichever URL that I want. Okay, so what we're going to do is in our session, okay, I'm going to say, I want you to follow, okay, nod says follow the link to this path, where's the new page that I want to go to? The new page I want to go to is going to be Margot Robbie's page. And once we do that, we're going to scrape the content. Okay, so we're going to do session, and we're going to do, scrape Margot Robbie's page content. And once we have Margot Robbie's page content, then we will get the list of kind of projects that she's working on. And so I can say, hey, I want that list. And again, we get a big, bold, beautiful journey. All right, so I'm going to do this. I'm going to do this for kind of automatically for the first 4 actors. So I'm going to do a for loop. I'm going to say for actor name in the first 4 cast members. Okay, what we're going to do is we're going to take our existing session, follow the URL to the new page, scrape the content. Once we're on the actor's page, okay, from the actor's page, we're going to scrape the list of projects. Once we get the list of projects, there's other, like I'm going to try to get the years, and we're going to do this. And so this will take a few seconds to run because we told it to be polite. So before it visits another page, it's going to wait and it's going to kind of just check with the browser, am I allowed to, or with the server, am I allowed to go on? So it takes some time, right? So it's running, okay? And we're going to just kind of wait, sit around. So now it's done. It's visited the 4 pages. It's downloaded the information from each of the things. And we've been storing all of this into a big list, okay? Into a big list with each actor's name. So if I look at the list, we can see my list. The first item is Margot Robbie, and then we have her movies, the years of the projects, and then I just duplicated the name a bunch of times. Then we have Ryan Gosling, his projects, the years those happened, and I duplicated his name a bunch of times. Then we have Issa Rae and her projects and the years those things are. And then we also have Kate McKinnon. And so all of this stuff has been stored in a big list. And so now what I want to do is I want to kind of arrange it in a table. So I'm going to kind of create a new list where one column is going to be movies, one column is going to be the years, one column is going to be the names. And I'm going to kind of just append all of these things. Again, this is the bad form where I take the existing thing and I just copy the existing content. But for a small loop, I think it's okay. And so here it is. Here's our list, and I'm going to format that into a data frame. And now I have the results of kind of going through, and these are kind of the 10 most recent projects for Margot Robbie, 10 most recent projects for Ryan Gosling, Issa Rae, Kate McKinnon, and so on and so forth. And we have kind of all of these, the results of scraping the web and visiting these different pages and getting their different kind of projects and information from visiting all of these kinds of things. So I think that's pretty neat. Okay, and again, you can do quite a bit with Arvest, but it works best with, or really only works with, kind of more static pages, things that aren't going to be updating, every few seconds or something. So things like your Facebook feed and Twitter are not going to work because those would require logins and stuff. But if you imagine a site that is relatively static, okay, then it will work. So like even like an Amazon page where you have like product information and stuff, it could work for that. But anyway, that's what we have. All right, let me give you your last view quiz answer. Last view quiz answer is the letter A. A as in apple. And we will wrap things up there. Have a great weekend, and we'll see you next week.